Jane Low at the Quantum Summit here at Singapore Expo. And today I'm very pleased and very privileged to have Dimitris Angelakis, who is the principal investigator with CQT, which is the Center for Quantum Technologies here in Singapore, as well as the founder of AngelQ. So thank you so much, Dimitris, for joining us today.
Thank you for inviting me, Jane.
Yeah,
Very
Dimitris.
happy to be here.
Yeah, great. Dimitris, you're going to be giving us a sort of a quick tour about what's going on here in Singapore in terms of quantum technologies and all that. So really grateful that you can spare some time. So if you want to give a brief introduction about yourself first.
Yes. So, as you said, I'm the founder of AngelQ Quantum Computing. It's a new startup we're spinning out on quantum software and quantum computing, working on industrial use cases, helping people to become quantum ready.
Okay.
And separating hype from reality. As I like to say, I've been a professor of quantum physics for almost 25 years here in Singapore, and I also have a affiliation in Europe, in Greece, in my home country.
Yep.
So, at Technical University of Crete. And I want to stay in quantum for another 20 years.
Right.
So we
cool.
have to be very careful what quantum can and cannot do, and how to optimally implement that for the industry.
Oh, excellent. That's great to have you here to tell us about what is reality versus hype. First question, which you also mentioned in your talk earlier. So quantum has grown, obviously, over the last 20 years since you studied on the subject. And it has now quite defined verticals, as I understand. So we are talking about quantum communications network, quantum-enabled devices, and quantum computers. So can you tell us what are the differences between these three sort of verticals?
Right. So that's a very good question. Yes, the industry and the science is kind of common behind all these three. It's the science part in terms of quantum physics as an enable to do either better sensing devices. That's what quantum sensors are, to start from that, where you can make much more efficient and accurate detectors, let's say, of gravity, which you can use to detect whether underneath the earth there is oil or there is a gap or there is water, or very finely tuned clocks, atomic clocks, that can calculate time in a much better efficiency. That's under the sensors. Or you can make many really efficient detectors of various chemicals based on quantum physics. That's the quantum sensor side. It's on the industry now level. It's a technology that is quite evolved. There are prototypes out there that also made here in Singapore that work, and there's some startups on that side. There is quantum communication is the second part, which is about secure communication, secure messaging between sender and receivers, because as you know, the first thing quantum computers will do will break cryptography, will break crypto systems, will break the RSA protocols. We have the proofs, we have the algorithms. Of course, the hardware is not there yet, but nobody knows when it will happen. So this is exactly why we need quantum communication, quantum secure communications, which is the counterpart, is the alternative for to build quantum safe encryption. So, and the first part, which is where I work and is most of my research focus, is quantum computing. So quantum computing, you can imagine it in a very rough way as a super fast, super efficient computing, but that's something I don't really like so much to put it in. It's just very different computing than anything else we had as a human race, all the way from the antiquity and the abacus to the supercomputers of today. The abacus is this very basic device that my ancestors, the Greek or the Babylonians, used to calculate one by one. Actually, our classical computers still calculate one by one. Quantum is something very, very different. It's based on quantum physics and allows you to exploit very complicated notions but very real notions of naturing, superposition, and entanglement, to develop algorithms that can do much more than anything else we know as humankind so far. This can have applications in optimizing networks, in transport, in sustainability, in the finance sector, in machine learning and optimization, as we say, which cover a lot of areas. You can do quantum enhanced versions of all these things to really outperform classical computers and solve unsolved problems in industry so far.
Right. You talk about optimization problems, simulations, machine learning type applications. So all these are potential areas that where quantum computer can come in and perform better than our classical computers because of its quantum properties like entanglement that you and yeah, right. So you mentioned in your talk earlier as well, for an organization who is looking to be quantum ready or thinking about quantum, one of the first steps they have to think about is thinking about whether in their organization they have any sort of optimization problems. So that is a potential area where they can think about using quantum, because quantum is a lot better than classical computers.
Very good, very good. Exactly to the point, Jane. The entry point is very simple. First of all, organizations need to, this is new technology, and they are justifiably kind of worried, what does this do? How does it work? Especially as quantum is so exotic and esoteric. One entry point is to see on the digital adoption, on the classical computing adoption, what kind of tools they use for their use cases, for their sales, for their operations. Quite often, some companies, larger corporations, but also smaller ones, already are exploiting some basic AI or basic optimization tools to a certain level, quite often in a very preliminary level. Then one way is to see what are the bottlenecks next. Do they get very inaccurate solutions, or it's very inefficient or very slow? Then there could be quantum enhanced layers on top, and that's what we can do for them. We can help them to develop those quantum capabilities that go and sit on top of the classical AI tools to provide an enhancement, an improvement, and at the same time get them quantum ready, help them to prepare their own roadmap for quantum, because every company is very different. Some of them, as we said, may have some basic AI or classical computing capabilities. Some of them don't even have that. They might even be at the level of conceptualizing certain problems. They might not even have the mathematical model to describe some of their use cases. They might be based in very heuristic and very inefficient. That costs actually a lot of money and a lot of resources to the companies. And the more I do this, the more I put on my entrepreneurial hat and I talk to companies, I realize that the adoption of the scientific thinking itself, the mathematical thinking, is very low in certain cases. So you start from that, you help them conceptualize, build a model, you help them put on top of that a classical AI solution, which we will fine tune and will make it efficient for their use case, and then the quantum comes and sits on top. And that actually provides value throughout the structure and gets them quantum ready as well, because the software we actually give them at the end, the API, the solution, is hardware agnostic, can work with classical or quantum and can work with very different quantum hardwares as well.
Okay, so that's actually brings me to my next question. So when people think about quantum computers, they think about all these IBM photos that we see in the media, this huge computer that has to operate under certain sort of physical conditions. But what you're talking about earlier is you can provide companies with APIs whereby they don't actually have to have this big structure.
They don't have to have that, and they should not have that as well. I said in my talk, my collaborators and partners from IBM and Google might not like it so much, but it is true. I mean, quantum computers are not machines that you buy now and you put it on your table. Maybe if you are a very big corporation or a bank, maybe you can have one on your basement later on and so on. But now, what is needed is to have partnerships with quantum enablers and quantum software providers like us that can help them to develop the use cases, and then you can run in these machines via the cloud. This is actually the business model as well for most of the hardware companies, because quantum computers now are physics experiments. They are very, very big. You can get one in-house to test certain things, but it's not something you can put on your office or
Of
your
course,
desk.
yeah, that's
It
right.
requires liquid helium temperatures and minus 273
Right.
degrees, and it's like the ENIAC in the 1950s. Not everybody can have an ENIAC in their
Mm.
office, but what you need people that can program the ENIAC, and they can also teach your technical, like the company's technical people, how to program the ENIAC without having to spend 5 years to do a PhD in quantum computing. So we provide that layer, that software, that API that allows the customer, even with no expertise in quantum and with very little or even no expertise in classical AI, to make use of some of the solutions connecting to the cloud and or to simulators. You can also run a lot of things in classical simulators, or also in what we call hybrid quantum classical, that you use a quantum and a classical computer next to each other to do things.
Right. Okay. Yeah. So that really demystify, a lot of these misconceptions that people have, that if they want to deploy quantum computing, they need to think about all this hardware infrastructure, which is a big challenge, I think.
No, not at this stage. It's not that the same way you buy a GPU these days, and there's a lot of discussion about GPUs these days. You go and buy a QPU and put it on your machine. You change it, and it won't work. There's no QPU that will just be slide it in a slot and
Right.
provide.
Okay.
There are machines based in different places of the world. We build machines here in Singapore.
Oh, I see. Okay.
Some of the
Right.
big companies have their own these days. It all started from universities.
I see.
There is a lot in the research in the universities and spin-outs of universities, which you can connect by the cloud, and then you use what you really need. You need the solution, you need the API and the algorithms that are relevant for your use case. Because again, that part is not fully developed.
Right. Okay.
And each use case, each industry is very, very different.
I see. Okay.
So it's not one size fits all type of
Okay.
approach yet.
The other sort of challenge that people also hear when it comes to quantum computers is the noise factor. Is it something that organizations have to worry about when they implement one of these, or think about implementing one of these solutions, or is it sort of a technical kind of challenge?
I think they should be worried as far as the hype is concerned, but in the sense that we do have large machines. Again, let me use this early 50s computers analogy, that can do amazing things like in the 60s and 50s, or even say 70s now. We are that corresponding era. We have a lot of quantum technical challenges. This is the quantum noise you're referring to, because quantum systems are very fragile to external influences. Slight increase in temperature or a slight increase in the magnetic field that you can't control will affect the performance of your processor. But we're learning how to control that in a very efficient way. So I wouldn't say that the user needs to be worried about that if he's using software and algorithms that they are designed properly and they are robust against that. And that's exactly what we're doing. We actually co-design our algorithms based on the hardware partnerships we have with hardware providers, so that they're efficient for the hardware and they are protected against the noise and can deliver useful solutions that make sense even now. At different industries, at a different level of value. In certain industries, quantum is more mature, so you can get some business value even now. In some others, you are still at the proof of concept stage, that you try certain things. It's not that easy to build, to beat classical computers. Classical computers are very good. So the moment, what you can do is you can develop your own quantum roadmap. You can see how, with our help, how relevant quantum is for you. You can get the API that works with any backend and with any hardware, including the classical. And as quantum evolves, you'll be ready to exploit the disruptive nature of the industry, and you are not going to be left behind, because that's the most important thing. Now, the quantum computing will happen, and it will really hit it big very soon. So nobody wants to be left behind.
What do you suggest that the company's KPI factors should be when they think about deploying quantum? Will it be about just pure performance?
No, I think first they have to come with an open mind to see through usually a partnership with this quantum solutions and quantum software companies, consulting companies like ours, or a university, to learn about quantum, to understand and demystify the subject. So there are programs to do that and understand a little bit more. As also in AI, we have the same problem in the AI adoption, but in quantum maybe it's a bit more. What can and cannot do, the number one. Then the best thing is to try, again, in partnership with the quantum industry, a POC, a proof of concept, on their own use case, on their own use data. I think that's what I found very important. People really appreciate it more if you don't talk academically to them about what is possible in 50 years or 30 years and exponential speed ups, but you really try to solve a problem, even if it's not of direct business value now, for them on their own use case. And you deliver a solution that works and can be extrapolated as the hardware evolves into something that has business value, maybe in 2 years. So that's the best way to go in. Certain industries, though, other, for example, in optimization, in route optimization, in shipping lane optimization, in aviation, in also materials and sustainability, then you can actually see you can get very reasonable performances and certain value even now. So if your algorithms that you're using are developed efficiently, even this current gap with the hardware, which is closing as we speak, but for that you really need what we call qubit efficient algorithms. So that's our unique contribution via AngelQ Quantum Computing. We have algorithms that work with the current state of devices. We don't have to wait for 10 or 15 years. In certain cases, of course, and they are not horizontal because the field is evolving, but there are use cases for industries that you can get very, very exciting results now.
So you talk about like 2 years, so that's sort of like the average for a POC to run.
The POC can start from 6 months. There are POCs of 6 months, and there are more deeper R&D projects for a year or 2 years. It depends again the industry, how much have they adopted AI and machine learning already. Because if that layer is missing, we help them to develop that as well. We do that part also, because the quantum sometimes comes and sits on top of this, and that's a kind of a process. So it can be 6 months, it can be a year, it can be 2 years. For certain more mature industries, they can also join through what we call a software as a service model we have, where they can go and they can use our GUI, our API, and just put on the data and they pay a subscription and they get solutions. There are industries in data analytics, for example, or in, again, optimization, that this can be done now. And we do have the solution ready. So you can go and you get a login and a password to our website, and then you can run your use cases there.
So I guess the login and the APIs is not free if anyone is listening to this.
It comes with a price. It's gradual. You can test for certain small instances for free, and it will be. We have not launched it yet. We are coming out of stealth soon, and we'll make a public announcement. But it will have 3 layers. The entry layer, which will be certain things, will be for free. Then the middle layer, which you can do more. And with charge, and then the elite, where you can really get business value, and that will be more highly. But it will be relevant, of course, to the value that you get. So there will be a layer approach.
So the most important thing is for organizations to go back and think about whether they have optimization problems and whether they actually already have AI and machine learning sort of capabilities.
What are the bottlenecks that they are facing at the moment, like in their operations? Like an airline company, for example, might be facing bottlenecks in assigning planes to destination, optimizing routes, cutting down costs. Shipping lane for shipping companies is similar. Transport is similar. Scheduling problems. These are all under optimization. The quantum computers can help if you have these efficient algorithms that we do develop. But also in banking, in financial sector, there's all this fraud detection, quantum Monte Carlo methods.
Oh yeah, of course. Right.
There is this anomaly detection. There's many use cases that there are certain interesting applications of quantum computing as it is now, if the algorithms are optimized, like in our case, that can be run in NISC, what we call NISC, small machines, and provide some interesting proof of concept understanding for the industry and see exactly if this is relevant or not to them. It might or might not provide business value now, but it will definitely get them ready by designing their own roadmap and exactly knowing when to act how through this process. That's the whole idea.
Right, yeah. So thank you very much, Dimitri, for giving us such a sort of a practical insight into this quantum technologies and developments. And of course, many people, when they think about quantum, they say, oh, it's just a lot of hype. But obviously, as we just see, there's a lot of practical use cases as well as a lot of practical developments and POCs that has already run. So just one last word from you then. So for anyone who's saying, quantum technology is a hype, what's your response?
I don't think it's hype if you talk to the right people. So just pick your partners carefully. Do partner with quantum startups that are serious and they have proven to be, built by serious people. And don't be afraid to explore this new technology because it will happen. Quantum cannot be stopped. It's a disruptive technology like in the past semiconductors technology, which again based on quantum physics 50 years ago, like the steam engine technology that it started from physics 300 years ago and led to the Industrial Revolution. Quantum will happen. So you better be on board and on the train before it leaves, because then it will be very difficult to catch up.
Yeah, so really two key takeaways then. Pick your partners carefully and go back and think about the problems that you have in the organization that require optimization and simulation solutions. And that's where quantum will add tremendous value.
Exactly.
So thank you very much, Dimitri.
Thank you.
Thank you for your time today.
Thank you, Jane. That was very nice.
Thank you.